So, thank you. So when we look at this one here, this is going to be the first problem we're doing today. But the first thing we need to do is, one, look for restrictions, and two, make sure all the denominators are simplified. They're simplified as far as they'll go. Now, out of these three, the first two, the x minus 2 is as simplified as it gets. The x plus 2 is as simplified as it gets. But our x squared minus 4 is not factored. It can still factor. Now, there's not a greatest common factor we can pull out of x squared and 4, but x squared minus 4 is one of our special polynomials. It is a difference of perfect squares. So we'll have plus and minus. Because x squared is x times x, and 2 and 2. So x squared minus 4 factors to x plus 2 and x minus 2. And once we have that factored, we can look for our restrictions. Now, there are 4 different sets of parentheses, or 4 sets of terms in the denominator. But we only have 2 that are unique. We have the x minus 2, and we have the x plus 2. And we can set both of them equal to 0, because whatever value of x that will make either one of these be 0 will be our restrictions. For the x minus 2, we would add 2 to both sides, telling us that x cannot be 2. Because if x is positive 2, it's going to make 1, or really 2 of the denominators be 0. For our x plus 2, we would subtract 2 from both sides, telling us x cannot be negative 2. So our 2 restrictions for this here are positive or negative 2. If we get one of these two as a solution, then it doesn't work. So now we can start solving. So what will we need to multiply everything by to get this to simplify? Because we're trying to get rid of the fractions. So one of the things we can multiply everything by is indeed x plus 2. And if we multiply everything by x plus 2, the one on the far right, the x plus 2 and x plus 2 would cancel. The one in the middle, the x plus 2 and x plus 2 would cancel. And the one on the left, well, nothing simplifies. Are all the denominators canceled out or simplified out? No. We also need x minus 2. Because the one on the far left, the x minus 2 and x minus 2 would cancel. And the one on the far right, the x minus 2 and x minus 2 would cancel. Any questions on this so far? Now let's see what we have left. In our first one, we'd have 5 times x plus 2 minus 2 times x minus 2 is equal to 3. Now at this point here, we just need to simplify. So for the first one here, we would distribute the 5. 5 times x is 5x. 5 times 2 would be plus 10. Here we're going to distribute the negative 2. Negative 2 times x is going to be negative 2x. Negative 2 times negative 2 is going to be plus 4 is equal to 3. Now again, since the variable x, biggest exponent's 1, we just need to get it by itself. So here we can combine like terms. 5x minus 2x is 3x. 10 plus 4 is plus 14 is equal to 3. Next thing we can do is subtract 14 from both sides, telling us that 3x is equal to negative 11. And last but not least, we would divide by 3, telling us x is negative 11 thirds. Is that one of our restrictions? No, so that is the solution. Questions on this here? Are you ready for the next one? Now this one here, we can look at the restrictions first, but we do need to make sure all the denominators are factored. Now our first rational expression, 5 over x plus 2, the denominator is simplified. However, the other two denominators are not. So if we looked at 2x minus 4 first, there's no square, so we can't factor it with sets of parentheses, but there is a greatest common factor of 2 that we can factor out. And if we factor a 2 out of 2x, guys, we're left with x minus 2. So we factor the 2 out, we get 2 times x minus 2. And the last one we need to factor is the x squared minus 4. And again, just like the last one, this is a difference of perfect squares, giving us x plus 2 and x minus 2. Now again, when we look at restrictions, the only two places that we can get a 0 is either with x plus 2 or x minus 2. The scalar of 2 here doesn't have an impact on zeros because we can't affect it. It's just a number. So we're mainly looking at x plus 2 and x minus 2, guys, for zeros here. So for the first one, we would subtract 2 from both sides, telling us x cannot be negative 2. But the other one here, we would add 2 to both sides, telling us x cannot be 2. So just with our last problem, x cannot be negative 2 or 2. Now the question is what we're going to need to multiply everything by to get the fractions to simplify and make it easier to solve. One thing we can multiply everything by is x plus 2. Because on the far left, the x plus 2 and x plus 2 would cancel. On the far right, the x plus 2 and x plus 2 would cancel. What else do we need to multiply everything by? X minus 2. Guys, if we multiply through, thank you, by x minus 2, the middle x minus 2 would cancel, and the one on the far right's x minus 2 and x minus 2 would cancel. Are the denominators completely simplified? What else do we need to multiply through by? 2. Because now the 2 and 2 will cancel. And at this point, we can see what we have left, guys. In the first one, we have 5 times 2, which would be 10, times our x minus 2. Minus, we just have our 2 times x plus 2 is equal to 3 times 2, which is 6. Now at this point here, we can distribute. So we'll multiply through by 10. 10 times x is going to be 10x. 10 times negative 2 is negative 20. Here we can distribute the negative 2. Negative 2 times x is going to be negative 2x. And negative 2 times positive 2 is going to be negative 4. Now at this point here, we can combine like terms. 10x minus 2x is 8x. Negative 20 minus 4 is going to be negative 24 is equal to 6. At this point here, we can get x by itself, so we can add 24 to both sides, telling us that 8x is equal to 30. And last but not least, we can divide both sides by 8, telling us x is equal to, we can simplify, which tells us that it's 15 over 4, because 30 and 8 have a common factor of 2, which would reduce. Any questions on any of this here? Guys. This here is the last one we'll look at, then you'll have the rest of the time to work on the assignment. What we need to do here is, one, make sure all the denominators are factored, which they are, because the first one, x minus 2, is factored. Our second one, x times x minus 1, is factored, and our last one, x times x minus 1 times x minus 2, is already factored. So we don't need to do any factoring. Now we also need to figure out what our restrictions are. The first one we can find is for x, because we need to see what value of x is going to make x equal 0, and that is just 0. So one of our restrictions is that x cannot be 0. The next one we can look at is with x minus 1. Well, here we can add 1 to both sides, telling us x cannot be 1. And the last one is x minus 2. Here we can add 2 to both sides, telling us that x cannot be positive 2. So if x is 0, positive 1, or positive 2, those would be one of our restrictions and will not work in the original problem. So what do we need to do next? Yes, we need to multiply each by x, x minus 1, and we have to multiply everything by x, x minus 1, and x minus 2. Now in the first one, guys, the x minus 2 and x minus 2 will cancel. Our next one, the x and x minus 1, will cancel with the x and x minus 1. Our third one, everything will cancel out. And on the other side of the equal sign, it has no denominator, so nothing will simplify. Now our next step is to multiply these. Well, 1 times x minus 1 is the same as just saying x times x minus 1. Plus 2 times x minus 2 plus 2. Well, what is 0 times x minus 1 times x minus 2? 0. Yeah, because anything times 0 is still 0. Now at this point here, we do need to distribute, so we can distribute the x. X times x is x squared. X times negative 1 would be negative x. Next, we can distribute the 2. 2 times x and be plus 2x. 2 times negative 2 is negative 4 plus 2 is equal to 0. We can combine like terms, telling us that we have x squared plus x minus 2 is equal to 0. Any questions on how we got to this point here? Now, at this point here, the number in front of x squared is 1, so we can have integer solutions, numbers without a decimal. And whenever we have those, what we can do is we can graph it. So we can say x squared plus x minus 3 minus 2. And we put this in here and hit graph. Because whenever we graph a quadratic or graph a higher degree polynomial function, we're looking for what value of x is going to make it be 0. What values of x are going to make the y values be 0? Where is it going to cross the x-axis? If we go second graph, it'll give us a table. So we're looking for what value of x makes y be 0. And we do have 2. We have 1 at 2 and 1 at 1. So it's telling us x is equal to negative 2 and x is equal to 1. So these here would be our two solutions, but what? X cannot be 1 because that's one of our restrictions, leaving x equals negative 2 as the only solution. Any questions on this here?